Hello, welcome to the stream. This is again the Stinger robot rebuild where we're working on, let's pull him out over here. This little guy that was designed as a sort of outreach robot, training platform, everything by a group of students that did a capstone project in our mechatronics program last spring. And as can be evidenced by, sort of pieces hanging off, this is my fault, in no way the student's fault. I wasn't quite aware of just how violent visitors to the career fairs and things, the outreach events that we take these robots to, can be. So the goal was to sort of create a version 1.5. 1.5 because electrically we're shooting for the same thing, but we're shooting for something like this prototype that another student worked on. It's a little more modular, a little more tanky, if you will, to try to get this guy a little more survivable, out in the field. So the core of this sort of redesign is this custom circuit board here, which eliminates most of the wires and a lot of the sort of problems that came from those things coming unplugged, solder joints breaking, stuff like that. And last week on the stream, we got started. I'm going to go ahead and switch over to my Onshape. Last week, sorry, I try to mute when I cough. I'm just getting over a cold. But last week when we got started, open it up here, we sort of we got done with sort of just the platform or the portion of what will end up being the main robot chassis that will actually accept the board. And this is where we left it off. And I got to say, this was a hard thing to walk away from. I mean, I'm a design nerd. I would have loved to finish this guy, but then, you sort of run out of streaming content in 1 week's time. So I think the goal for tonight will be to see if we can't get motors and batteries in this guy, at least, if not further. Of course, we'll keep going. And sort of my plan, just besides just working on this redesign, my plan for this series is to sort of go through my thought process, sort of what a designer is thinking about as he goes through these things. So I talk through a lot of those thoughts. It's very stream of consciousness. There's a lot of undo, a lot of delete, that kind of stuff. So let's go ahead and hop right in. So we left off here with what we called the chassis, and these little cutouts are intended to allow, I'm going to make this guy transparent. And I'm still, of course, learning Onshape and remembering where my things are. There we go. Make transparent. Now, the one thing I haven't figured out coming from SolidWorks is how to sort of make this quote permanent. Because in SolidWorks, when you change transparency like that, it's that way until you turn it back off. But for now, I mean, I just want to, so these, the little cutouts in that, what will end up being a 3D printed chassis, are to allow for the pins and the solder blobs on the bottom of that main circuit board room to fit, so that this board will sit flush. And if you watch the video from last time, we just sort of guessed at how deep and how wide and things. And if looking at the actual physical circuit board, um, as long as we're sort of outside all of this white screen printing where the letters and stuff will be, we've got plenty of room. The solder pads aren't very big at all, so these pockets will be just fine where we've got them. I'm gonna flip over to the chassis though, and I think the next thing to do will be to sort of create the screw pockets, or rather for the not pockets, the bosses. Sort of, we need more plastic. We're going to insert these screws. So let me switch to the full screen here and see if we can't get a decent view. So on this version, in the original, I told the students not to worry about inserts. I've had very good luck in the past, and actually this one will be better to show. I've had very good luck in the past with just running threads into 3D printed parts. The thing that I wasn't counting on when I gave them that piece of advice was there's very little bite on these little M2.5 screws that hold a lot of these other little accessory circuit boards in place. So in all cases on this redesign, part of the robustness is going to be using these little guys. Give me a zoom, give me a focus. Little brass heat set inserts. So, we design a hole for these to go in. There's a little soldering iron tip that's designed to fit right in here in the sort of little diameter. You get it hot and just sort of push it in place. So we need a place to put that. And actually first, before we sort of decide on a place to put it, what I would actually do is I go out and find what I need, because a lot of times, especially since I'm buying these from McMaster Car, they will actually come um, on the website and let's go to McMaster. They'll have oh look, it's in my history. So we don't want tapered, we want just heat set, not tapered. And I like these because honestly, in the past too, if I get lazy, I don't actually have to heat it. I've had pretty good luck just pressing these guys in place, in various plastic parts. So I know for a fact that the screws that I've designed that circuit board for, this guy, that these were clearanced for a 1024 screw. Now, I decided, I think, that we want to stick with all metric, because most of the other circuit boards that are purchased, that get mounted to this robot, are metric. So I want to stick with metric. It's a hole for a 1024, which, if I remember right, is an M5. Now, my mind never converted to metric, so I usually cheat. And when I need help in the realm of conversion sizes, little machine shop. This I have been using for like 15 years or more. This is my go-to tap chart, so it kind of tells me sizes, for clearances. So an M5, let's see, an M5. Now these are tap sizes. That's not really what I wanted. What I probably want is I want to find something that has, does it have a major diameter? It does. It does not. Well, M5, 5 millimeters should be the major diameter. So, let's see. Pull out the handy calculator. Again, I've always got a little piece of scrap paper and a calculator handy because I don't convert well in my head. So 524.2 is the major diameter of an M5, and a 1024 minor diameter is 0.138. That seems awful big. Did I go for a quarter 20? Ooh, now I may have to take back my previous I know for a fact statement. So what is this telling me? That is a 0.2 diameter. And if I look at the taps, or the major diameter, M5 is going to be a 204. That might be too big. We might be able to cheat it. I'm going to go with it. If it's a 0.2 diameter hole, M5 measures 204. Honestly, at this stage in the design, because frankly, I've already got the circuit boards in hand. I'm going to rely on the fact that circuit board material is soft, like the FR4 that it's made out of is soft material. So for 4 thousandths of an inch, I can, sort of push it in there. So I'm going to go with that. I'm going to go with the M5. So back to McMaster. I want the M5 insert. And then as part of this series is to, sort of talk through my thought process in doing this. I thought that would be useful for folks for some reason. I mean, maybe I'm a nerd. Somebody else might be out there too. My thought here is I want the deepest insert possible. Not that I'm necessarily going to use the deepest insert possible, but if I design for the deepest insert possible, that means it'll accept any of the shorter ones, right? So M5, we come in here, they've usually got a drawing. They tell me maximum hole diameter 6.5 millimeters. General rule of thumb, if we were tapping this hole, and I'm not going to tap it, is that we need a wall thickness, or the boss should be double the diameter. So we would add a screw boss at 13 millimeters. And that's kind of what I'm going to stick with. There's even less stress on this thing if I decide to heat it when the assembly happens. So that rule may not strictly apply, but that's what I'm going to go for anyway. So 13 millimeters, converting again on a handy dandy graphing calculator. I'm even a nerd. It's the same graphing calculator I had in high school. 0.511, we'll call it a half an inch, I guess. And so what I'm going to do, now I have to think, how deep do we need? That drawing should have a minimum thickness. So 10.3 millimeters, back to the conversion, divided by 25.4 is 0.4. So I'm going to just go 0.5 deep and 0.5 in diameter. So I'm going to sketch on this surface, and actually I want to do it in the part, not on the assembly this time, but I'm going to sketch on this surface because these are going to stick down. And we're going to sketch and give me a good straight on view and just start dropping in circles. And right now it doesn't matter even where, how big, because they're all going to be the same. So I can just select them all and hit the equal constraint, make them all the same, give them the half-inch diameter, 0.5, and then I can start grabbing these centers. And since I've already sketched the board layout and left it on here, I did that on purpose, I can just start hitting coincident. You could probably also get away with selecting the circle and doing, concentric to give you the same result. But since we've got points, we might as well use points and coincident and grab, right? So we've got circles, we've got a sketch. That's all we need for these right now. Grab that sketch, extrude it, and we definitely only want a half-inch, okay? I don't need the full half-inch off of this bottom surface, though. I need the half-inch off of this surface. So I am going to attempt, let's see, blind is correct, but there should be, starting offset? Is that right? Nope. We don't want to do that. I thought that there was a way to send this. We don't want to do up to the end. These are all end conditions. So this is that's not gonna be what we want. Did I really want to, now the question I'm asking myself is, did I really want to sketch it on the bottom? Because I could have sketched it on the top, extruded a half-inch that way and just been at a half-inch or whatever. Yeah, I mean, the other option, really, if I want to get lazy, is just call this good at a half-inch from here. But part of my goal in the back of my head is to keep this thing as light as possible. So what I'm going to do is I'm going to see if this will allow me to change the sketch plane. Let's see, rename copies. Yeah, show dimensions, add selection, hide. Hiding doesn't do me much good. What if I just, can I edit? Look at you, sketch plane. What if I change you to here? I mean, looks good. Seems good. Ooh, that's a problem. That's a problem, but I can get around it. So I'm going to extrude that. I'm going to extrude this. I'm going to give it my 1/2 inch, 0.5, because overall, whoops, wrong direction. So edit, wrong direction, that way. So now from here, if I select both, I should have a 1/2 inch, yep, down here on the right. And here's going to be something less. So 370. Now, that's ugly. We're probably okay because there's so much extra clearance in all of these pockets. Did it hit any other ones? Doesn't look like it. We're probably okay. I don't like it. So I'm going to see if I can't, because we didn't define the screw boss features based on these pockets. I should be able to grab them and drag them up above. Will you let me? There we go. If I drag them up above, maybe. No, did it? No. That's the cutout, yes. Oh, it just took it, okay. It just took it a second to re-render. Yes, so now my screw bosses are above, it cut through, everybody's happy. I do that quite a bit, sort of cheat it, to get things to fit that way. So next, that's right, and so for a similar reason as what I just did, I'm not going to put the holes in right now. I envision drawing the motor, adding the motor mounts, and they'll stick in a ways. And if they happen to cross these screw bosses, I don't want to fill in those holes because there's the potential to have a lot of features that I have to drag up above and remember what things are and stuff, and I don't want to do that. In the case of the holes for those inserts, it's going to be better, I think. I mean, I don't know, but I think it's going to be better if we just leave it, do the holes after, and we can do that anytime. I've got the sketch, right? I can drop holes right in there, be nice and concentric. Everybody's happy. So I guess let's go after the battery. And for that, we went with, we were at Adafruit for the battery. It's the Adafruit website. And I'm working from memory here. I do have the bill of materials, but if I remember, we were at this guy right here. What is their part number? So 5035 is Adafruit's part number. A 10,000 milliamp hour battery. Now, it turns out with the actual use of these robots, this was insanely overkill. Like, I want to say I ran this thing for 8 hours a piece at 3 separate career fairs and never had to charge one of these robots. So insanely overkill. I like it though. That means that I'm not likely to be stranded in the middle of a career fair with dead batteries. So I'm going to stick with this one. Even though, I mean, honestly, from a design standpoint, it's kind of ridiculous. We could save a lot of weight alone just by optimizing the battery, you know, and getting closer to, I don't know, an hour or so. But I kind of came to like the overkill. So we'll leave it here for now. Somewhere in here, what I'm going to look for is a data sheet. Aha, data sheet. And hopefully, data sheet has got dimensions. It does. Where did it go? Oh, right there. I'll zoom in a touch. Is that actually zooming the PDF or just my whole browser window? It looks like it's zooming the PDF. So, what do we got? We got a 100 millimeter plug. We've got 69 millimeters by 56 millimeters by 19 millimeters, right? So the 56.5 by 19 is really the hole we're looking for, so that it can, you know, sort of slide. And actually, this is a good example. This one, the prototype version 1.5, slides in sideways. We could do that. I am thinking I would rather do it long way and get more mass of these batteries towards the middle of the robot. I don't know why. That's just my first instinct. Get that mass closer to the middle. So I think I want to do it long way. So we'll do the 56.5 millimeters, which is what? 56.5, 25.4. 2.25, so call it 2.25, or 2.22, I should say, call it 2.25, so 2.25 by, how deep are we? 69, 25.4. That's 271 and some change, so 275. And of course, when I do this, I am going to build in more clearance than that. I do not want to hold, what is that going to be? 2.5 thousandths. So 1.25 thousandth per side. I don't want to try to hold that on 3D printer. That's a little snug. And honestly, this is not going to be perfect anyway. I mean, do I have a battery? Can I just pull that one out? Is it that loose? This one was kind of snug in there. Yeah, that one's kind of snug in there. Let's see. Come on. No, I'm not going to break the leads off. I'll get it out later with tools. But um, what I'm thinking is the covering on those batteries is not going to ever. I mean, they're wrapped in shrink wrap. Effectively, it's never going to be perfectly those dimensions. So giving it some clearance, on the back end is a good thing. So there's the dimensions of the pocket. The height 19 is 25.4. That's 748. So we're going to call that 3/4 on the nose. And again, I'm going to build in some clearance on that. So let's go ahead and pop in a battery pocket, shall we? We want to flip back over to our tabs. Now, if I want to show the top view of this thing. So if we look with how that is oriented, I've got the battery in the back of my robot, and we're oriented this way. So we're going to be adding the battery pocket on the bottom of what's the top in this view. So here. And I mean, I can extrude it off of this face or the bottom. It's not really going to matter much. I think I'll just do it off the bottom. Let's sketch. We'll create a rectangle. I think I actually want to draw this rectangle off funky, not centered on purpose, because I want to grab the center. Can I grab the center? Will you let me? Well, when it won't let me grab the center, I'll just drop a dot in. Drop a point, grab that point and this edge and constrain it to the midpoint. There we go. So now we're centered. What did I say I had to have? 2.25 wide. 2.25 wide, but we got to add wall thickness because we're going to be extruding the outside. I'm going to be extruding the outside and then extruding a cut into it to actually sit the battery in. So 2.25 dimension, where are you? Right there. 2.25 wall thickness. 1/4 inch is a little beefy. So if I went 2.5, that would give a 1/4 inch per, or an 1/8 of an inch per side. We could try it and see how it feels once we get it in there. So let's do that. 2.5. And this is right here exactly why I didn't want to cut into that hole, because when I extrude this, it would have filled in the hole, and then I would have had to remove features. So a little bit of planning ahead. Not that I plan everything ahead, but so 2.75. That one, if I want an 1/8 inch wall, I really only need an 1/8 of an inch because the back is going to be open. So 275, make it 2.875. Is that actually going to work? Now that I'm looking at my physical one, I'm looking at where those screw bosses ended up. And I'm thinking I'm not going to end up liking that placement. We may actually, I'll see what I'm thinking is when we go to cut it, if we cut into this screw boss too deep, we won't have enough wall. We should have enough wall for the brass insert, but what I'm worried about then is the brass insert's going to impede on the inner area where the battery needs to sit and not give us enough room to squeeze the battery in there. That's what I'm really worried about here. But I mean, the beautiful part about CAD is it can be undone, so let's do it. Why not? Extrude. out. We don't. Oh, it helps if you select a sketch. Select the sketch. We definitely don't need the inch. 0.75. And again, if I'm shooting for an 1/8 inch wall, um, 0.875 gives us that, right? If the battery was 3/4, 875 gives us that. It looks kind of funny, it does, but I mean, if the goal is light, I mean, at some point, funny might be the order of the day, you know? So, I mean, for now, I'm going to call that good. I'm going to go here and I'm going to do another sketch to produce the battery cutout. Now, the question, how fancy do I get? Because this battery is, you know, shaped like what in SolidWorks would be a slot. I don't think there's a slot tool here. It might be, I mean, maybe buried in one of these guys. I didn't really look that close. There's an ellipse. Yeah, I don't see a slot. SolidWorks would call it a slot, but you know, this shape, rounded on the ends. Do we want to get fancy and make the pocket for the battery rounded, or just cut a rectangle? This one is just a rectangle, but this one was designed to go in sideways, not lengthwise. Let's do it. I mean, we're 3D printing the thing. We can get away with some nuts. So, I mean, if this were, this is already well out of the realm of anything I would design if we were shooting for machining. If we were shooting for machining, I would very much be going the route that this one took, where we start out with a block roughly the size we need and start cutting into it. The whole idea of starting with as minimal and adding on is that I know I'm going to 3D print it, and we can get away with some crazy stuff on a 3D printer that I wouldn't ever attempt, you know, if I were machining. So let's sketch this here. I know I want an 1/8 of an inch wall at least on the bottom. So let's do that. Because in doing that, I mean, that's the way I designed it. Once we get all the rest of the dimensions of the battery in here, we should be good as far as clearance. We can't go too tall. Remember, we gotta be under sort of this level in order to give our pins room on the circuit board. So that's going to be kind of the driving, the sort of drivers to make sure it's low enough so that when, like that height was 3/4 of an inch, I'm going to bump it up. I mean, 5 thou should be okay. That will probably end up snug. Like I've mentioned in the past, I don't really have the printers at Baker dialed in sort of the way I do my ender here at home. Like I know here I can hold 5 thou without a problem. At the ones at school I haven't played with, I don't know what they're actually capable of. So what I did was grab a line from the midpoint of my sketch to the midpoint of this face, or this edge down here. I am going to set that to construction so that I can set it vertical, and that's now going to center my battery pocket, or what will be my battery pocket. Now, width was 2 1/4. Actually, that 2 1/4 was, if we're going to plan for the fact that it's oval, that 2 1/4 was this 56. And they say that that's max. I got to be honest, I don't trust that that's max. So if you see max on a drawing, all right, I should be able to create my pocket at, say, 56.6 millimeters, and it'll fit in every time. I don't trust that they're holding that. I mean, I just don't. So we're gonna go with the safe play. However, to make that work, and we want to go rounded, so I'm going to construction both ends because I don't have a slot tool. And then I'm going to grab arcs and, you know, make one. So, looks like I have construction still on. We can fix that. We can make them not construction. So drop those in. They're already fully constrained. They should have tangency. Oh, they got midpoint, so midpoint even better than tangency when you're doing this. So select them again and unconstruction. There we go. Now, because I have the dimension from here to here, I need points there in order to dimension it. So I'm just going to drop points there, and that was the 2 1/4. I'll give it 10 thou, 5 thousandths a side. So 2 1/4 becomes 2.26. That somehow seems as if my math was off, does it not? No, 56.6 is correct. Is there another? Okay, just I haven't defined that yet, that's all. So honestly, I have next to no complaints about Onshape. Coming from SolidWorks, I mean, I've been able to jump right in and do some pretty cool stuff. It's missing, I mean, my workflow is obviously off. I mean, I've got to remember to click off of things to deselect them instead of just escape, stuff like that. I got to be honest, the only complaint I have is how much things move when you dimension them. Like, dude, is there any reason to make it that big? Just because I set the length? That might be my one complaint. So height wise, we were at 75. So again, I guess 10,000 we go 76. Yeah. Yeah. Sounds good to me. 0.76. I mean, we'll have to see. We might get into that pocket. We're awful close to that edge, especially since I didn't account. You know what I could do? So I could drop this down to account for that 0.12 to account for that extra 5,000. Just now I should be like perfectly flush with this. Nobody's worrying, and I mean, who's going to stick a micrometer on my 3D print to make sure that that was exactly 1/8 of an inch on the bottom? You know what I mean? So now grab that sketch, extrude it. We want to cut, so we need to hit remove, and 1 inch isn't good enough. It's 275 on this one. I'm going to make it even deeper, because I know for a fact on the end of these batteries are little boogers of the shrink wrap that they put on them. Come on, slide out of there. Really wish. Well, I guess a yank is about as good as I'm going to yank it out of the slot. Come on. Just get enough to get my fingers on the actual batteries. So there's some extra goodness here where like the solder connections are and stuff, and there's some extra, you know, where they're welded on the end. They're not perfectly square. I'm going to give it 50 thou on the inward side and hope. I mean, at the end of the day, if it sticks out a little bit at the back, it's not really a big deal. So we'll go with that. So if I give it 50, that's 2.8, right? 2.8 deep. And that gives us a very, very thin wall down at the end. Ouch. Ouch. But that should be okay? Question mark. Accept that. Again, I mean, this is CAD design. There's nothing here that can be undone. The reason to go through all these thoughts and the design process is it's a lot cheaper to change it right here than it is after I've, you know, spent 12 hours trying to print this thing. So, I mean, it's 3D printed, right? So 3D printing, even that's just time. The real cost is if I were planning on machining this thing and screwed something up. I'm going to live with that. I am going to live with that. The reason I'm spinning it around right now and still questioning if I'm happy with how thin that is I know at the end I'm going to want to fillet these edges, and there's not a lot of meat to do that with. Why don't I do it now? I mean, I just got done saying that things could be undone, so let's give it a good healthy fillet. What was the radius on this? 3/8. Okay, so we can give it because I mean, in my head I'm kind of thinking in the end I would like this to be a nice radius that sort of matches the inner pocket. So we'll give it a good healthy radius and see if I can fit that all the way around. 0.63 is definitely not big enough. What did I say it was? 0.4? Oops, 0.4, something like that. Let's grab that. I mean, close enough for when it's printed in plastic, right? Not perfect, but let's grab that. What happens if I do it here? What happens if I do it here? Okay, it is not going to like that, I don't think. I think if I remember right, when it turns pink like that, it is something it's not happy with. Let's try it. Yeah, it didn't like it. Edit. Um, that would be the last one there. So it likes that, and then we can probably get it get that same all the way around if, if this were the end game, but what it really doesn't like is that end. And probably because we're filleting into the pocket. So I'm going to go ahead and make that deeper. I don't like that. But like I said, at the end, I'm saving all the filleting for the end because as I start to add more and more features, what I've found in the past is if I say fillet this corner, in fact, I can do it and delete it. Let's fillet that corner. What I have found in the past is that if I do it now, inevitably, 10 hours from now toward the end of the design, I'm going to want to dimension something to this corner and it's not there anymore. So then I got to go back anyway and delete the fillet, and it's just a mess. So why bother? So let's delete the one that's broken, delete the one I just did. So I leave it till the end most of the time. And that wasn't always something I did. That was something that I learned to do after getting my ass burned many, many, many times. So really what I want to do for now, that's the cut. That's the meat that we're deselect. That's the meat that we're cutting. I'm just gonna add some to this. For now, let's just go 1.125. Add a quarter inch to it. Whoops, that's depth. Cancel. Cancel. I've got to change the sketch because that's how we defined it. Edit. So if I want to add a quarter inch, where are you? Okay, so it's going to be 3.125. I still don't know if that's going to work for the fillet that I think the big fillet I want maybe at the end, but let's see. Let's try it. I go here now. Now it's happy there. If I go here, it's happy. Okay, so that tells me that'll be enough. And then can I still go around? Whoops, whoops, whoops. Get rid of that face. Get rid of that face. There you go. I want that edge. So, and we can play around later. At least it's happy doing that, right? Can I select that? Cool. So, I mean, that'll be kind of a cool profile when it's done. So yeah, that's enough material there. How big do we look? It's not terrible. Quarter. I mean, it's a quarter inch, right? Or 3/8 maybe. So it's not a ton of extra weight. It gets us, in the future sets it up for kind of what I want it to look like. So we'll call it good. Yeah, and that's really for now anyway, all that's left for the battery. Now I can foresee, so out on this edge of the PCB, let's go to the assembly. And bring it back to the view we had. This where it says power boost. That's the booster that takes the 3.3 volt battery up to 5 for the rest of the sensors in the Arduino. So eventually the battery wire has to go out and plug into a PCB that will be mounted on this connector. We can and probably should in the future when we get that far make a nice little cutout here so that the wire has a place to rest. And maybe we throw a piece of electrical tape in it over it to hold it down, or we even design a cover or something. I don't think I like the idea of a cover. I kind of like the idea of leaving it open, but you get the idea. Something, we can come up with a place to put that wire later, or like realistically, it can just sit out there hanging in space. I mean, we've got nothing too complicated. The power board or booster, let me unplug the USB here. The booster, is something, where are you? Something very small like this. The battery, it will sit on the view I've got right now sits on just like this, and the battery plugs in on this outer corner. So we can just leave it out in space if we want. We can tuck it in, come up with a nice like channel to run it through. All kinds of options. So we're going to call that good for the battery for now. The battery should slide right in there, be happy. The next thing I would like to do is go with the motors, and get the big blocks similar to what I just did for this battery, get similar features in there for the motors. And actually, in looking at this, I think we're okay on that screw hole. This is the way my mind works. I just jumped thoughts like 6 steps ahead. I think we're okay on that screw hole. I'm still not going to put the holes in because we're not done like adding plastic yet, but we're probably kind of okay. So motors. Motors. I'm going to pop over. This was the tab. Those also came from Adafruit, and like I said, I do have the bill of materials. I'm being incredibly lazy and not opening it, and I'm just going to find it on here. It was their gearbox motor. It was their TT, but it was the TT motor with the metal gearbox. I am not sure what the difference is. We do not have a double-sided axle. That much I know. I think we had the all-metal 3802. Yeah, I'm pretty sure that was it. In fact, even if it's not, they have the same housing. So this is the guy that we need to get in there. We've got dimensions. Now, that's not good enough. I need, like, if this thing is going to mount like this, right, I got to know where these holes are, right? Rough length, width, and depth are not good enough for what I need to do here in this design. So I got to find, I mean, technical details is just a section on the website, so that doesn't help. We recommend wheels add-ons. That's a different drive. That's the motor drive we will be using. We need ideally a solid model. I mean, a solid model would be great. So, I mean, one of the things I do a lot when doing a design like this, especially with purchase components, let's see, Adafruit, what was it, 3802? Hey, I've already searched for it once. I was going to bring this up. I'm glad I don't have to search for it in my history. This is an awesome website. Now, I've mentioned this is actually my second to crack at this version 1.5. I started this way, sort of with a big block that I was carving, and I thought I could make it look way cooler. So I scrapped it, just deleted the entire project. But while I was doing that, I found this GitHub repository that I don't know if Adafruit owns or what, but it has solid models of a ton of their stuff. And as a mechanical engineer, the number one gripe I have when it comes to designing parts for circuit boards is not having actual solid models. This one, 3802, that's the motor we're looking for, but this has got a ton of their part numbers in it. Not all of them. I did find a couple that I couldn't find in here. I had to go elsewhere. But it's got a ton of CAD models for the various things, and most of the stuff that I'm going to end up putting in this project. So I'm just going to go ahead right here and download it. Any reason I shouldn't? In fact, I think I probably did once. So I don't need anything but the step file. Grab that, download. Give it a sec. Step downloaded. I can come here, insert, import rather. Step. I'm going to create this composite. Again, I don't fully understand this composite part because sometimes it does it where, like, instead of an assembly, you get one part. Or sometimes it doesn't. It gives you an assembly anyway. So I click it and hope. I got to be honest. That's sort of what I'm doing. Give it a second. All right, has been imported. So we got a part. We got one part. Looks like it came in as one part. I'm kind of curious if... Now I've got one of these in my hand, and I'm going to point something out when it comes time to put this in the... when it comes time to put this... to start putting this thing together in the model. So first, though, I'm going to try to get it in the assembly. I want to see if it's actually a part or if I go and drop it in here if things are going to move. So let's do that. Let's insert. It doesn't call it a part. Composite part. There we go. TT Metal Gearbox. And I don't care about the color. I can set appearances and stuff later. In fact, that's something I'd like to play with. I was Googling around, and it sounds like this has a pretty cool render functionality. So I'm just going to mate this guy. Though if the whole thing moves, I mean, it's not looking like an assembly to me. So I think we're okay there. The whole thing moved. So I'm going to get rid of that because I actually don't want that planar mate because we haven't put any material in to mate this thing to yet. So let's get rid of that. Now we have to sort of make some decisions because I don't have a great. I would prefer a technical drawing. And while I was able to obviously find this GitHub repository, I was never actually able to find a good CAD drawing of the thing. There's nothing in here that I missed, right? STL is not going to do it. JPEG's probably not going to do it. Nope, that's just a picture of the model. I got all excited there for a second. So let's go back. Yeah, none of these are, I mean, STL step, none of these are. So I don't like this. I would prefer a drawing, but what I'm going to actually have to do, there's two ways I can do this, and I'm actually going to do both because this makes me nervous. I need to know the hole pattern, the mounting holes. So there's 1, 2, 3 mounting holes. I need to know where they're at. I also need to know the dimensions of the motor itself. What I'd like to do is inset it into plastic, sort of the way that I need to invert or de-invert my camera for the next stream. But sort of the way this one is, where it's cut in, I want to do the same sort of thing, just to give it a little more support if things get torquey. They shouldn't, but I want to have some plastic there to sort of help it out, not just rely on the screws that are mounting it. So I need dimensions off of this guy in order to know what I need to, model here. And the reason I don't necessarily like that is I don't trust that this is accurate. And one of the big reasons I don't trust this is accurate is if we look at this motor this way, and I'm going to flip to big screen. So we look at this, well, no, I won't yet flip to big screen, but if we look at this motor this way, these two tabs are kind of here, right? These two tabs, and then it's flat on this whole mounting surface is flat. The actual motor, give me a focus, is not flat. I'll click over to the full screen quick. Is not focus. The motor is your focus. Do your job. Where those solder connections are for the leads, there's another bit of plastic that sort of hangs out, and I think it's intended to protect those a little bit, but it is definitely there, and it is definitely something that makes that whole back surface not flat. So I need to account for that, and that's one of the reasons I don't trust just using the solid model, and why I say I would really, really like a CAD drawing. What I am going to do is reach into one of these drawers because I, again, didn't prep any of my measuring stuff. I'm going to grab a caliper so that I can get a depth and a sanity check to see how much I can trust this model is to start checking easy features and see how accurate they are. So from here to here, that little tab should be 118. If I stick my caliper on this, what do we got? One, oh, not even one, right? No, is that zeroed? It's close. Always make sure your calipers are zeroed, folks. It's very close. It's like half a thou off, but I'm picky that way. What can I say? Tighten that back down. Check it again. I was off by more than half a thou, but what's the point of a tool that's not reading correctly? That's only like 75 thousandths, so that's not even 0.1. So shorter, I mean, shorter's good. If I make a pocket off of that thing, some sort of pocket to accept that, deeper's better, right? If I make it based off the model, it'll be deeper than the physical one, which is good. Width, they've got 276. I got 200 on the nose ish. 202, 202. Yeah, 202. Let's see, what else can we double check? So that's good, because if I size it to this model, size a pocket, like if I have flat plastic on this mounting plane, put a pocket here for this tab and size it for this tab, I know it'll clear the physical part because the physical part's smaller. There's no point in measuring that little space, that little extra tab where the leads are, because that guy, I mean, I'm gonna have to account for it later anyway, so we'll figure it out. But screw holes, let's see, there's extra plastic here. Can I get in those screw holes? Screw holes look like 118-ish. 118-ish, anywhere close to that, because there's extra plastic. We, at one point, some of the students attempted super glue to hold these motors on, and some of the plastic came off right at the screw hole. So anywhere, if this thing measures 118, anywhere near that, I'm happy because of that extra. So the diameters are right, or appear to be right. So if I measure now here to here, and now normally you want to be very careful. Normally you want center distance. And in this case, I don't even think you want that. I think you want probably, I don't know why parallel, they must not be parallel holes. Probably drafted or something funny. Normally this would say center, but I'm thinking parallel axis is the same as center in this context. My guess is if we were to really measure these things, they're not square for some reason. They're either tapered or, yeah, it kind of looks that way. They don't look quite cylindrical if you get them from the right perspective. Anyway, yeah, so normally I'd want center. In this case, though, I want max because I got a pair of calipers in my hands. And the easiest thing for me to do to double check is to check the max, right? Open it up, check the max. So max, I've got 815. 827. Right? 827 is what they're telling me. But those holes, these holes are also not, let's not grab the holes. Let's grab the part I'm measuring. Just the outer surface and see what it says. Min distance maxed is 827. I mean, 10 thou would be a lot. And that's what I'm getting. 815 now. Ooh. Ew. Ew. Of course, I mean, at the end of the day, I guess we're mounting plastic into plastic, and if it's off by that little bit, I can shimmy a little and scrape a little. And what does this one measure diameter-wise? The other, like the one that's out in the back, 115, also diameter, so pretty consistent there. What are you telling me your diameter is? 118. Well, I'll take it. So they're the same. They're all the same diameter. I'm going to write that down. 118. Because now I can go back to that tap drill chart. 118 on a clearance. Let's pre-convert that. 0.118 times 25.4. Right about 3 millimeters. So 3 millimeters, if we look over at the clearance side of the world, a 3 millimeter screw is going to be too big, right? Because this is 2.997 is what 118 comes out to. So 3 millimeter screw, I might go with a 3 millimeter. That, again, that's for clearance. Do we want to end up through it? We want a mounting screw? I mean, maybe. M2.5. I suppose we could go with 2.5. I'm trying to think because I bought for the prototype the other student did for this prototype. I bought some, and I'm trying to now think what I can recycle out of what we already have. So, and I unfortunately don't have them here at home. They're on my desk. I do believe we bought M3s, M5s for the big circuit board, M3s for one of the other ones, and I think we bought M2.5. M2.5 will work. It'll just mean we have a pretty sloppy hole, a pretty sloppy motor mount. But we also have then the plan is going to have plastic on each side of this guy, to help it. And we've got 3. Yeah, we're gonna go where M2.5 for now, and hope we don't come to regret it. Sounds like a good command decision, right? So let's do that. And I mean, always if I have to, we can put the M3 in later. A little bit of drill. That's not what I wanted. I wanted this. So we got to get this guy in here. Now, one other thing. Ooh, I can't measure that. I didn't actually get the wheel off. I want to know how deep this thing needs to be set in. So I'm gonna, looking at this, it looks like this, motor physically in my hand sets the wheel way further out. Like this shelf looks way further out from the body in the physical motor than it does in the model. Ooh, and they dripped super glue down there. That's not great. Anyway, so what do we want? We want to know the height of that shelf, and it is not much. Let me tell you that right now. In fact, I don't even think I can measure it. I think I'm just going to trust. I think I'm just going to trust the CAD because I can't. There's no way I'm getting any of the tools I have here to measure that on there to measure that shelf. So we're going to trust the CAD. What I'm going to do is I'm going to plan for this surface to land flush with this surface. Right, that'll be my goal. That way, the wheel should be outset beyond that at least this distance. Which, again, looking at the physical motor, isn't a ton, but it is clearance. I mean, an inch is a mile, right? Stick with what you got. So, best way to do this is going to be what? Best way to do this is going to be what? I think what I'm going to do is I am going to, similar to what we did with the battery, but I'm going to grab this surface, draw the box that this thing's going to fit in, and then cut into it for the motor. I think that's the plan. I think that is the plan. I think that is the grand master plan. Yeah, so let's do it. Now the only other question, like I said, this end of the motor, right, says on the model that this whole surface is flat. It is not flat on the physical. Where those wires are is an extra bit of plastic. If I can get it lined up, extra bit of plastic that I got to account for. Now my question is going to be, should I let that hang out the end? Like, should I let that, and it's going to be, how big is that? If I let that hang out, I got to eyeball it because the shaft will be out there. The motor shaft will be out there too. Eyeballing where that motor shaft is, that's a total of pretty close to 400 thousandths of an inch, call it half. That'll be sticking out the back. I don't think I like that. I think I want to make sure this right here, the furthest point back, which is the shaft of the motor, the front half here is the gearbox. I think I want that here, even with the back. I don't think I want it sticking out the back half an inch. I don't believe I'm going to like that look. And how the wheel, there's one other design concern, but we can figure that one out in a minute. I think, but do I know? I don't know, because we're talking through this in what's become a maniacal rant. There's one other consideration, and that's going to be the fact that I need to make sure the power board sits on this connector and hangs off in this direction. And I need to make sure that when I throw a wheel on here, wherever this axle lands, the wheel is not going to hit that power board. We can, this whole rest of this side from basically this edge of this connector forward is a wide open. Like that wheel can do whatever it wants as long as I get it past this plane. Yeah. So, I mean, actually, I don't think I looked. Let's look for the power board. We got that Adafruit thing, right? The power board was, again, I'm being lazy. I don't want to open my bomb. I just usually find it by looking for battery charger. And in here somewhere, I know it's a power boost right there, 1000 or 1000 charger. It's this guy. It is their part number 2465. We go here. And let's see, 2465. I don't remember finding it. 24. Oh, I must not have looked very good. Oops. Where'd you go? 2465. I was between clicks. Rev B. Excuse me? Excuse me? What rev are you? I don't remember seeing a rev anywhere. What is Rev B? Tell me. Tell me what is Rev B. I mean, optional USB on the back. So the students, they put their USBs on the back. They just soldered them in place just in case. So that it can power the Arduino through the USB. But it's optional. And in fact, with this single circuit board design, we don't need to do that because all of these power pins have been traced through the board, the custom PCB. We got the battery connector. That's a micro, which it always was. I don't understand what Rev B is. Does the printing say Rev B on it anywhere? Could be that guy. I don't think it's that guy. Could be that guy. It's possible. I mean, I don't really have a choice. I don't want to model the thing. They've got a Rev B, so I guess that's what I'm going to use. So let's download that and get that guy imported into our Onshape, and we can get it mounted in the assembly. Again, I'm going to click that composite. It worked the last time. I don't know if it'll work this time. I'm, like I said, very much not sure what that actually means. I have an idea, but it doesn't seem to do it all the time. Like now, notice I got, this time I've got 2 assemblies and a bunch of parts. Right? There's a whole bunch of parts right here all on top of each other. But then when you look, you get the actual full assembly, and I definitely don't know what the difference is between these two. PCB component? I don't know what that means. What happens when I bring it into our assembly? Let's insert assemblies, Adafruit Power Boost Rev B, boom. And I did not group it. I talked last week about how to group it and save the heartburn of all these parts moving around. I did not group it because I want to see, because this assembly looks to me like that whole assembly, and it is a sub-assembly of this assembly. And I'm wondering, because it's buried 2 sub-assemblies deep, do I actually need to group them? I probably do. I'm about to find out. So I want to mate planar this surface with this surface. And, okay, we definitely need the grouping. I'm going to cancel that. I am going to I'm going to just, I guess, start at the top down. So I like to start with the board and make that the fixed thing. So let's fix that. Then we select everything, shift everything, group them all. Now I don't know if I need to group them here. I guess I'll find out, because again, it's a sub-assembly of another assembly. We do want a planar mate on the bottom of that board to the top of this connector. Hey, it all moved, so I guess we're happy. Now, what I just did is not accurate. There will be, when this is fully assembled, headers here, pin headers, that will include this extra height of the black here, the same height. I don't really care right now that I'm off by this much height, because if I can design it in such a way that the wheel clears this lower, that means it'll clear it higher. So that level of accuracy, to be honest, I don't care about in this design. It's just a thing I'm not even worried about. But what I am going to do, I can't, well, I could. I really could. In SolidWorks in the past, I have mated holes like this to square recesses like this. I have. It's a pain. It usually requires construction sketches, and then you mate the sketch points. I don't really feel like doing all that, so I'm just going to hide this. And I can just add slider mates or even cylindrical mates. Slider, probably cylindrical, to the holes, because the holes line up. They're on the same spacing. They have to be, otherwise my pin headers will never line up. So I can do cylindrical there, boom, and I should be able to grab one on the other end. Do cylindrical there, and the other extreme, boom. We like that. It flips itself. We get rid of that. Nothing is red. It's happy. If I grab it, it's not dragging around. Cool. The little, let's see, though, I hid something that I now want to unhide. Ooh, where'd you go? Where'd you go? I want to unhide it just to show it. Well, of course, just to show it. Why else would you unhide something? Unhide, show. So there. Now again, it's short. It will be at least the height of this black plastic here taller. But if I clear the wheel in this position, I will clear the wheel in that taller position, right? And that's clearing the wheel right now is really all I care about. I mean, it's really all I care. Now, the other option, do I want to do that? I kind of do, now that I thought about it. So what I'm going to do, man, this is me nerding out. And this is why it takes me so long to do CAD design. What I really want to do, now how many pins is that? 1, 2, 3, 4, 5, 6, 7, 8. These are 8 pins, right? Yes. I have this part because it came in as a part of my board design. I didn't create this part. It was automatic just by the fact that I exported a solid model out of KiCad. So I've got this part by default because it's part of this assembly. I can add it to this assembly. And I'm going to take a minute and add it to that assembly. I am not happy about it, but that's the way my mind works, and otherwise it's going to bug me. So I'm going to delete it. I'm going to go into this. I might as well add it to this assembly. And insert. Stinger parts should have it. I don't know. It should be a pin header 1x8, right? Pin socket, not a socket, pin header. Pin header 1x8. Okay. So now that's in there. Now I will show you the annoyance that is doing what I just decided to do. So I need to sketch. Actually, I can edit this in context. I don't want to really open the tab that it's on. Let's edit in context just so I can sketch on it right here. Whoa. Excuse me? Oh, because it's in the other part studio. Oh, crap. That's not good. I don't want to do that. Exit. Get out of that context. Get out of those parts. Go back here. I don't want to do that. Can I open it from here? Normally I would just edit in context, but given that it's on top of all that other stuff, I don't even know what pin I'm looking at. So isolate, make transfer, and I'm just trying to see if there's a way that I can just like hop to it. Isolate? Nope. Let's go to the parts and see Pin socket 1 by, or it's a pin header 1 by 8. Pin header. That. Can I drag you? I mean, this is a part studio, not a assembly, so no, I probably can't. I don't like that. I don't like the way this came in. I'm not nuts about it. I don't know how to do anything about it. But I guess, I mean, I can sketch. I can't select the face of that part, though. This is bothering me. Can I break that out into its own part studio? Let's see. I could. I want to create a drawing. I definitely don't want to do that. Copy. You're not going to let me paste, are you? Not going to let me paste. Damn, that was worth a shot. Delete. Let's see. What can I do? What can I do? What can I do? So if you... What good does copy do if I can't paste it? Copy. Paste. Now what if I edit this one in context? It's still that one. It's still that one from the big mess of parts. I'm not letting this go. This is now, you know, my honor's at stake. So let's delete the extra one. Ooh, there's a move to new subassembly. Can I do that? Maybe if I could get this out of here and into its own part studio, I think we'd be in the clear. Export maybe? Is there like an internal export? Nope, that's going to get it out of... It's going to get it out of here. That's for like 3D printing. I don't want to do that. Gotta be a way. Hide. Oh, I could just hide the other parts. Why can't I do that? Genius. I'm a professional. Let's sketch. Now, the easiest way I have found in the past to do what I'm about to do. I mean, first of all, don't do it if you don't have to. But I'm on this bottom surface. That is the right surface. Yes, that's the surface I want. Anyway, I'm going to sketch just 2 circles at each end, one for each end of the pins. And the easiest thing I found is, if you can, to grab these points and just make coincident on each corner of the square. See, and that locks it down, and your circle is, quote, concentric to the pin. So when I go to mate it, it should be concentric to the hole, in theory. And everything I'm doing, of course, is because I'm a masochist, and it was going to bug me that we were going to be like, I mean, how tall is that? That is, I'll break out my handy caliper even without even measuring it, because I'm so angry at myself right now for doing this, for going through this. But, I mean, I'm told pain makes for good content, right? That's what I hear. So depth-wise, again, eyeballing it because I don't have a good surface to rest the caliper on. Eyeballing it. I'm going through all of this for under 100 thou. That's fantastic. It's the life of an engineer, right? So which one did I grab? I grabbed that one. Let's grab. It doesn't really matter what 2 you grab, because it should, you know, 2 points. Any 2 points coincident will make it concentric. Yeah, so we're going to accept that. I'm going to leave that sketch visible. I'm now going to come back to my power boost, where I should now have that sketch, which I don't, and it's not visible. And why? And why is it not visible? Because it is not a part of that part. So what do I do? What does create a task do? Oh, I'm gonna actually tell people to do stuff. Damn it. Isolate is what I did, right? No, isolate is not what I did. So I think, I mean, my big takeaway right this minute is that's not going to do me any good. My big takeaway right this minute is I'm not a fan of multiple parts in part studios. Honestly, it looks like a cheap and dirty way to kind of do an assembly without doing an assembly. And right now it's causing me a headache. There's got to be a way to get this part out of here. How can I do that? Can't pull it out of the assembly. Can I? Like, can I? I don't want to replace. I don't want to switch. Paste. Copy and paste didn't do what I wanted. Suppress won't do it. I mean, the other option is to just go out and to download a pin header. I mean, it's a common enough part. But I've already got one. It should not be this difficult to get the one I've got somewhere I can actually use it. So if I deselect and click it over here, 1x8, what options do I have? Because sometimes I've noticed I don't want to change I don't want to export. I don't want to switch. I don't want to replace. Honestly, I have no idea what best available tessellation is going to do. Isolate, hide all, hide other. Damn. There's got to be a way to get that in here in a manner with that sketch. Because I can't just sketch in the assembly. The only way that I know that I can do that is to edit in context. Oh, sure, there's my sketch. Why aren't you visible in the main one? Does it show up? It shouldn't show up separately in the here. All right, get out of that context. It shows up in here in the parts. You're starting to anger me. Now, I mean, this might be a thing to note for SolidWorks. Like, what is this? Create part studio in context. I don't think I want to do that. Create a new part studio in the context of this assembly. Context graphics for reference. I probably don't want to do that. And if I go and select any of these, I mean, like the big problem here is we got a square peg that I got to get into round holes. I mean, in the past in SolidWorks, I have cheated and I have mated like this edge tangent to like the inside of this. I'm not sure any of these mates that I'm allowed to do here. Like these are motion. I'm not sure any of these mates will actually let me do that. Oh, there's a tangent. What if we do tangent and go with this edge? And this. Okay. And then tangent. This is it. I mean, the sketch way is cleaner, but if it gets me away from this god-awful mess I decided to create, I'm all for it. Yeah, you see how things are wonky. I think I need to edit this one. I think it's tangent to the outside. And we want to be tangent to the inside. Did it move? Didn't look like it moved. Pretty sure it didn't move. I'm pretty sure it's still tangent to the outside. Tangent. Pretty sure it's still tangent to the outside. Edit. Flip. Flip. Okay. So we'll get rid of it. And now that the part is moved closer to where it needs to be, we'll try it again. So actually, let's mate it here first. Oh, and actually I did it upside down. See, this is a consideration, and this is a mistake I made when I designed the new PCB in the first place. Make sure you pay attention to whether these boards are going to be mounted to a PCB like this upside down or right side up. Otherwise, you end up with the pins in the wrong spot, like I was just about to do. I was about to put it on the wrong side of the board. It's got to be on the bottom. So we want to be planar here. I want to flip it. We're going to be planar in that direction because it's going to plug in this way. Now I should be able to get pretty close and do tangent. I don't think, I mean, I could probably also cheat and just line up this edge of the black with the edge of the PCB. I mean, I may just do that, but let's see if we can get the tangent thing to work, because this tangent method is exactly what I would have done in SolidWorks if I was feeling in a cheating mood. So let's grab this. I got the edge, and this. Make sure it's tangent on the inside. Flip. Why won't you go tangent on the inside? Are you just trying to cause me heartburn? You should go tangent on the inside. I mean, it's also possible that I'm just thinking of the way SolidWorks would do it, and this is behaving differently, but I've done this quite a few times in the software that shall forever be SolidWorks, and it has worked before. Tangent, maybe just because I'm grabbing the edge first? Okay. So see, the circle sketch method's better because then we'd be centered. We're not centered. We're not centered. I don't like that we're not centered. Just from a, being picky perspective, but let's do this one down here too while we're here. And good, and that should be locked down. It's not, but this guy I don't think was locked down. Like, yeah, that moves around. I don't know why. It's like a derived assembly. So all of those are off center. They're all off center. This thing's probably cattywampus. Like it is. I mean, I'm gonna live with it because it's really there for the height. So now I'm going to reinsert that assembly, that power boost. Crap, is that gonna float? I might have to regroup things. Let's try it. Planar mate. So now black on black will give us the right height. The height was really what I was after. Ooh, no, the height's not good enough. Well, yes, the height will be good enough, and I will show you why. Except I have to regroup all my parts. Let's see. Go back to the assembly again. Is the group a feature? No. No. Can I add you to the group? Yes. No. Did it group them? It certainly looks like it didn't group them. Let's try it. Oops, wrong. Again, alt-tabbing, back of the old SolidWorks days. So planar. I may have to go back in and regroup from scratch, question mark? Why would you not? I'm going to have to. Spikes. Oh, nope, there it goes. It refreshed. All right. Now, the reason that it will not matter that that's all cattywampus and it's moving in tangent in weird ways is because I'm not going to use these pins to mate to this. I mean, I could. It'd probably get pretty close. I'm going to do what I did before, though, and I'm going to mate the holes to the holes in this PCB to the holes in this PCB, which will make sure this lands in the right spot, which is going to be important because I am going to throw screw bosses out here in space to support the edge that doesn't get plugged in. I don't want to leave a PCB just sort of cantilevered off of a pin header like that. So I'm going to dive back in to the, what was I using? I think cylindrical. I'm going to grab the holes. Hole here. Crap, can I hide this now that I've... All right, fine. Get rid of that. Hide it now. Now I'll go, not slider, cylindrical. Slider would probably work. I haven't played with all the mates to see what's allowed and what isn't with the various ones. But that hole is this hole. Good. Into this hole. The last hole. Good. Everybody's happy. Again, I mean, this pin header is weird. If I drag it around, I might be able to get it in something resembling, excuse me, in something resembling, the right spot. And then it pops right back out. Cute, cute. You pop right back out. That's just lovely. Let's show that again and see if I can mate the pins to the socket just to make it happy. That actually, I mean, it doesn't matter. Right now, it's strictly me being picky. Where these land relative to each other matters not one little bit, right? And in fact, I don't even know if I can now move them enough. Part of the trick is not to move them enough to see a surface that I can mate. Like if I can grab one of these surfaces and mate it to one of these, it'll probably lock it down well enough. So let's try planar here and here. Did it do it? It did it. Did it freak out? It did. It freaked out because probably that tangent. What if? I mean, there's a parallel mate. What if I locked these guys parallel? Called a parallel. It's happy. Now, can I drag those around? I can still drag them around a little bit. That's okay. That's all right. And what if I did it to the end? Like, if I'm shifting that, it should be no, because it's going to be parallel no matter what, right? Let's just leave it alone. I mean, from a distance, it looks okay. And really, like I said, it was there for the height because I am going to put screw bosses here. I'm going to add plastic so that we can't catch either of these two holes because they're over PCB. I can't do anything about that. But I can add plastic out here to catch these two and give it some actual support other than just being cantilevered off of this connector. Being cantilevered off of that connector is probably a bad idea. Those connectors really aren't designed for that. Now, these front ones, we really are going to just stick sensors in there, but there's a big difference in that these sensors are in there. Whoop, get the camera right. They're in there vertically. They're not hanging all their weight off the side. Plus, I mean, frankly, if one of those sensors falls off the front, not much happens. This is our power converter. If this falls off, we get no power to the rest of the robot. It's kind of a big deal. So I want it supported, and we're going to support it. That's why I needed the actual height so that we knew how tall those screw bosses need to be. It's also why I needed these mated to the PCB holes and not this weird tangent that I did, because I need to know also, the dimensions out to where these inserts are going to land. And the weird tangent would have thrown that off by more than I'm comfortable with. This is probably as accurate as it is going to get now. Now, finally, like half an hour later, I can get back to the friggin' motor, which was the whole goal for why I put the motor in here in the first place. That was a tangent, and I honestly, at this point, 9:30 at night, I don't even remember why I went on that power board tangent, but at least it's in there. It's there. It's not going anywhere now. Let's do a motor, shall we? Now the question is going to be, which way do we want this thing? So I'm going to throw a parallel mate in. I want this. Now, assuming that's like flat, it may not be. It may be drafted for injection molding, which is kind of common. Parallel, come on. I want to flip you. That works. Good enough. Because the question that I want to ask myself is, do I want to mount it this way? And let's go drag it out here so that it's, clear of some stuff. It's going to end up, like I said, it's going to end up with the face of the motor, or the face of this gearbox, even with this edge, is what I'm going to kind of shoot for. And I guess, I mean, can't really mount it that way at all, can I? So if I mount it that way, or at least if I mount it anywhere near where I have it shown right now, I am right into that screw boss. There's nowhere for that brass insert to go. We can't screw our motor down. That's bad. And if this were on the other side, we'd be right into that power board. All bad things. So let's first of all get rid of that parallel. I kind of want to flip it around. So let's go parallel with the motor to the back and the gearbox up front. Did it flip it? It did not flip it. Is that what I just said? That's what I just said. So let's go that way. And I'm still going to run into that same problem. If I go flush here, I'm in too tight and I'm going to hit that screw pocket. So either I have to come way out here, and then what is it? My mounting screws are clear. I have to come way out here, make the robot that much wider. And make the robot that much wider. Or I have to come way forward. Coming way forward offers its own set of challenges. One, because it moves those wheels way forward. I guess I'm trying to look and see. Yeah, they were way back on the original version. On this one, which way did we have that motor mounted? On this one, we had the wheels way toward the back. And I'm just, playing in my head right now. What's the best play? I got to stay clear of those two screw pockets. Well, I got to stay clear of all four of them. But what is the best play? Wheel dead nut center. Wheel dead in the center would not be terrible. Wheel dead in the center would not be terrible. In fact, it might be better because we've got two wheels. The thing turns by counter rotating them. And that would actually make it closer to a true zero turn if they were dead center. So that might actually not be a terrible idea. Will it fit? Like if I want that dead center, I'm just eyeballing it. And I don't think I can get there. I gotta think on that. I don't think either direction I orient this motor. Where's that pair? Oops, nope, close. Why would everything suddenly break? Why would everything suddenly break? Okay, whatever. That happens, I guess. It's a thing. Everything just magically breaks because you closed a mate and canceled it out, I guess. Anyway, let's go parallel. Let's go parallel this face to the outer edge, so at least it doesn't tilt on me like it just did. And if I want to shoot for that wheel to be dead center, like dead center, I'm clear there because this screw boss is further in anyway. The PCB mounting holes are not symmetric. This one's further in than this one is. I guess a smart thing might have been to design that in, but I didn't know what the final was going to look like. So, at the end of the day, something has to drive the design, right? Either the PCB was going to drive the design, something was going to, you have to start out with something fixed to design around, right? There are so many variables in the start of a design. If absolutely everything is allowed to be variable, you're never going to get anywhere. Something you have to, even if it's just, I need to draw this at 0, 0, right? That's a decision. You picked a place to start. Some of these decisions can be changed later. Some can't. Technically the PCB could be changed. I could move that other mounting screw in. Probably I might have to move these connectors. But I don't want to do that because I've already ordered the motor or the PCBs. They're already sitting on my desk. I mean, I really don't want to do that. And yet, are we? Yeah, we're kind of into it. And yet, maybe not so bad. Let me cut the crap and throw another motor in there, the other side. I need the derived parts. Throw another motor in there so I can see what's happening. Parallel, parallel, parallel all day long. Parallel with the outer edge. That's good for now. I don't want to mount, I mean, I don't want to mount the thing vertical because then we're going to be ridiculously tall. And besides, it would have to be mounted. The wheel is 2 inches, I think, in diameter that we're using, which means in order for it to even hit the ground, it would have to be mounted vertical the other way that this is shown, which would go up, which would be through our PCB anyway, which doesn't really solve any of our problems. So, what do we do? Well, I got one in there that way. Let's put this one motor forward and see what it looks like. Parallel this guy to this guy. So put this one in basically now in the opposite way on purpose. I mean, I'm trying to come up with a design that's going to face them both the same way. But for now, I just want to see. So, I mean, looking at that, I got like all kinds of room. You know what I'm saying? I got like all kinds of room if I go out here with that motor facing forward. I don't know if I can quite get it centered. The wheel. That's not a hard requirement, but it would be kind of cool. Plus, I don't know how far forward I want to get. Spoilers upcoming. I think I've decided. So I mean, the original robot here uses the Arduino Giga R1 Wi-Fi, and I put that down as a spec when I assigned the project to the students because I didn't know exactly what they would want to do. And I figured that had the most I/O, communications options, everything from Arduino's side of the world, and it gave them the most options. And it turns out that the Stinger, like, we're not even using half of the capability of that Giga. So as I was looking through things and really looking at what I can do to make this not only more robust, but draw in more students at those career fairs and things with this. One of the ideas I came up with was adding bling, adding more stuff because we got the capacity, right? Like less than half of this Arduino board is being used. So, spoilers, I'm going to add some Adafruit RGB modules, LEDs. One thing I notice is that the little golf ball sized Ozo bots, the students at these career fairs are drawn to those. It's almost like, I hate to say it, it's almost like moths to a light in the dark. Like they see those LEDs, man, and they're all over it. And they, as impressive as this is, like students built this. The programs that the students are watching at these career fairs run were written by students, right? The students that are only a few years beyond them in school, and they're drawn to the ones with the flashing lights. Like, this is the coolest thing ever, but no, we're going to go to the ones with the blinking lights. So I think to make this version 1.5 pop, I'm going to add, I mean, basically ground effects, right? Add some LEDs somewhere. They come in like 6 LED segments. They're addressable. You can turn them on, different colors, all that good stuff. And we got the room on the boards. I don't remember, honestly. So yeah, right here. They're going to plug into a JST connector right here. And the NeoPixel from Adafruit doesn't actually use a communication line. It just uses a digital output from the Arduino. Now I got to be honest, not being an electrical engineer and only a passable programmer, I suspect what they're doing is I suspect they wrote their own communication and they're just pulsing this digital output. I think they're just they're probably, I haven't looked at any of the libraries, but they're probably just pulsing it really fast and making up their own communication with it. is my guess. Some version of that. Because on one output, I don't see any other way that you can address. I mean, it says they can address up to like 64 individual LEDs and turn them on and assign colors individually. They got to be communicating somehow, and since they're not using a comm line, I got to assume they're sort of faking it, writing their own. Anyway, all that to say, if I orient the motor like this, that is going to affect some of the plans of where those types of things go. Because honestly, my first thought was to sort of hang them down here like headlights, and we're going to kind of get in the way with all the stuff that I see now going on if I point that motor forward. At least if I point that motor forward and run it to the center. If I point that motor forward and push it all the way back, I don't know if I can push it all the way back because I do have to get a screw inserted here. And if I start to encroach on this, you know, the one for the board might hit this one. It might be ugly. Maybe not. I mean, I may be paranoid. But I'm almost thinking either in the middle or as far back as I can go. Like not like the two extremes, right, is what I'm thinking. I'm not thinking somewhere between these two. Like here, that looks like a good one, right? Either I shoot for dead center or I shove it as far back as it'll go, and it's probably as far back as I can go. I'm going to call, whether this is accurate or not, I'm going to call as far back as I can go as soon as this edge of the motor touches that screw boss. That's going to be as far back as I can go. So yeah, all that. Whoops. What did I escape? Damn it, I had that in a good spot. I liked where I had that. Get back out here. Thank you. Yeah, so all that to say, I kind of like that plan all the way back, I think. I don't have a good reason for that other than so forward, I was thinking weight balance, right? And turning radius. All the way back, the bulk of the weight of this thing by far is this battery, and all the way back looks like it centers. Well, maybe not. Maybe I do split the difference. Maybe I center it for the battery because the battery is by far the bulk of the weight on this entire robot. Or maybe I do that. Maybe I center it to the battery. So let's target that. And I also don't want to take forever. You know, it's getting late, and we kind of need to end the stream at some point here. So that pocket is 2.8. I'm just going to assume the battery takes up the whole thing. We know it doesn't because I built in clearance. I'm just going to assume it does. So if I shoot, I'm just going to call it 1.5 inches. Let's make the math easy. I want this axle, this center, to land 1.5 inches from this back edge of the chassis. Right? And I just made a decision. And I mean, are they in the same spot? They are in the same spot, I believe. Let's measure it. Let's not guess. So I was going to say this dimension. I think they're in the same plane. But let's check it. Let's get a center distance. 3.1. There should be no delta in the, Y direction. And there's not. So they're in the same plane this way. So if this one clears this screw boss, this motor, even though I haven't flipped it around yet, will clear this one. Right? Because they're in the same spot. So I can just play with one side for now and call it good. But I need this center to land 1.5 inches from the back. How I do that right at this exact moment, I have little to no idea. I suppose the best thing to do would be to create a little diagram on my scratch pad. And again, I mean, like, there's nothing on here. Let's get the glare off it. You guys truly trust me. Don't care. It's a throwaway scratch pad. Like, whoa, I must have hit I set my caliper box on my F1 key. My scratch pad is literally that. Like at the end of these sessions, I can safely throw it away. It has literally no dimensions, no nothing, just numbers written on it that mean nothing to me. Like the exact instant I write them down. Like it's long enough for me to switch tabs. That's about all it's good for. So the best thing, I'm going to create basically a diagram of these 4 circles and their dimensions from one another, and I'm going to use that as the basis for a pocket to hold this whole motor. And I think that is going to be the winning combination. I think. I don't know, but I think. So, I mean, just start grabbing diameters, I guess. So here, boom, to here, and I want to make sure which direction is that. I do not care about X. X is the red. I don't care. Right? I want Y. Y, which is 512. Now, I can almost guarantee the model for that motor is metric. So that's something to keep in mind when I go to mate. I'm not going to be able to use concentric mates. And like I said, it's not known. I will almost guarantee it, though, that I won't be able to use concentric mates because it is not exactly 512. It is whatever that is in millimeters. And in fact, if I do a quick conversion, 25.4, 13.0048, I will almost guarantee that model is exactly 13 millimeters. If I take 13 millimeters, let's see if it's within rounding. I don't even know, because again, I don't do that off the top of my head. 511811. So I will almost guarantee that it is 13 millimeters rounded up to 3 decimal places. SolidWorks does that kind of thing all the time. In fact, so much so that I am actually going to do this one trick, or this one set of dimensions in metric. So we got 13 millimeters. And I've literally now, I'm going to try to get the glare off of this and actually put it, literally just drew those 4, dots for those 4 holes. And I'm just going to start dimensioning 13 millimeters for that one. I'm going to use the shaft as 0. 13 millimeters for that one, here to here. Center distances. Always remember center distance. I care about the green. So 787.787 times 25.4, 19.9898. So if I thought that was 20, .7874. So I'm going to guess that is 20 millimeters in this direction. 20 millimeters. And then those are centered, so really I just need this to here. And center distance is the blue, right? Yes, is the only one there is. 709.709, 25.4, 18.0086. So I'll bet if I then take 18 and divide it by 25.4, 0.708661, rounded up to 70. So it is 18 millimeters between those 2 holes. 18 millimeters. So now, if my goal in life is to land this an inch and a half back from this, face, I can absolutely do that. I'm going to be 100 thousandths long, but I mean, what's 100 thousandths among friends, right? So let's, I guess, start sketching. Let's do this on the, move my chassis tab. I will also, not anymore tonight, but I will in the next stream also show you what I came up with to, clean up some of these tabs and get them out of the way. I haven't found a way to close them yet. I'm working on it, but I have found a way to at least get not quite so many as we import all these PCBs with multiple files and stuff. So let us sketch. I am going to sketch the rectangle for the feature that will hold that motor. I'm not going to dimension it yet because, frankly, I don't know what the dimensions are. And then I'm going to drop the dots in for the various holes. Boom, 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 and boom. Okay. I know these are horizontal to each other. Well, actually, let's do a left align. So I'm looking straight on. Those are horizontal to each other. These are vertical. Whoops. Whoops. Come on. Deselect. The escape key doesn't do it. These are vertical to each other. And I probably could have got away with drawing a line. Does it have? Yes, it does. So I take that back because the easier way to do this is not with dots, not with points. The easier way I should have thought of it is going to be using lines, because lines, remember, come with free points. Look at that. There, and then one vertical. I'm not going to end up using this dot except to say that you are the midpoint. Now, the other dots are the actual targets. So here was 13 millimeters. 13 millimeters. And everything moves again. That might be my one complaint. We're 20 millimeters to here. 20 millimeters. And then apart, we were 18. 18 millimeters. Okay. So this set of lines now is our motor sort of layout for mounting. And our box is going to be bigger. Don't worry, I will move it. We want this. Where's my dimension? This is the shaft, right? This is the hole that... Can I annotate? I've never actually looked. Can I add a note? Just like a comment pointing that out? That would be kind of cool. What do we got? Comments? Can I do that? No. Doesn't look like I can comment. Tag entity markup, maybe. I'll play with it later. But this guy needed to be 1.5 inches back from this edge. 1.5, right? Vertically, I do not know where it goes yet, but I'm about to figure that out. So let's go back to the assembly. And I could open just the motor and get the same answer, but I want to know center to center from the top edge where this is. So I don't want the minimum distance. I want center. 0.087. And actually this one I am going to leave standard because I'm going to clearance it anyway. I don't want this. I want a little more room. I don't want it right up tight against the top. Is what I'm thinking. So I'm going to go back here to the chassis. 087 is what it was. What do I feel like? 125, does that feel like enough? Kind of does to me. I'll call that good. So the holes are locked down. All right. Shaft and then the 3 mounting holes, right? Those are locked down. Those are where I want them to be. We should be perfectly clear of this screw boss. We're clear of everybody, right? Now we need the actual little pocket. I do want enough material. I want enough material to sort of cradle the motor. And the screws should be enough, but I want a little help, especially if I'm going with 2.5 millimeter screws, and they should be 3s. I want a little help. I want it to sort of sit in there and have a little plastic backing it up. So let's look at this assembly again. And how big are we? Now we can leave. I am going to leave a good hunk. And in fact, I'm only going to take that boss that this motor sits in out to here. I'm going to have it butt right up against this. That will eliminate the need for me to create a cutout for it later. Anyway, a little pocket. And if I leave it open and the motor, it looks like it's going to land somewhere almost exactly where I'm showing it here. My wires are coming out here on this side, remember, and then they'll be kind of sort of free in space to cross over or get wherever they need to get without any plastic in the way, and I won't have to cut a channel later. So it sounds like a bonus that I won't have to worry about. Well, what do we got for width? How tall does our little thing need to be? 882. I'm going to go 1 inch and give it some room. I can make it smaller later, but for now I'm going to go 1 inch to give it some room. 1 inch. Chassis. Go here. Dimension, where are you? 1 inch tall. Right? Again, I can go shorter later. There's nothing preventing me from doing that. Let's get then keep wanting to alt tab. Let's get the dimension from this shaft, this center point, to this tab, because that'll be the back of what I'm about to extrude. 1.582, and again, probably metric, 1.582, 25.4. Ooh, actually, maybe not. 40.1828. That looks kind of goofy. What if I do 40 even? 5.8, that's not 5.82. 40.2. That's also not. So, I mean, I'm thinking with this one, we stick with the old Imperial. Call it a day. 582. I do want to be a little short because I don't want to bind up, right? I don't want to hit it. And this little tab will also give me some torque. Give me some torque hold. So if the motor wants to, the gearbox wants to spin in there, this little tab hitting plastic on the way around is a good thing. From that perspective, I don't want to give it much. 5 thousandths, 2 thousandths. I'm honestly leaning towards 2 because if I go with a 2.5 millimeter bolt, I'm going to have a lot of wiggle in my holes. 1.58 sounds good to me from the shaft. 1.58. So let's do that. I'm also going to make these construction before I forget about it. Because those are really just references for the points. 1.58 is what I decided, yes. Here to here. At 1.58. And that'll be the end of that. Let's go to the left. Oh, God. It's really going to make me do that and not have that even. That is going to so bother my, that's going to so bother my sensibilities of, good design. That's, ugh. Now for this, how deep do I need to go? What I'm thinking, so the thought, again, the point of this whole streaming thing was to walk through my thoughts. So my thought, this is that outer mounting tab, right? Not the power boost. This outer mounting tab. My thought is this is going to land, like that tab is inside this screw boss, right? So where I have this drawn, this edge of the block I'm about to extrude is probably in exactly where it needs to be. Probably pretty close. I kind of hate it there because as I extrude it, it's going to hit this boss and there's going to be an ugly curve in and then back out to a block. I'm thinking aesthetically, if I bring this, even though it doesn't need to be that big, if I bring it all the way out to like the center, when it hits that, then will be kind of a nice curve back into the block instead of an ugly curve into the block. And that's sort of why I went, ooh. Is that what I want to do? That's kind of, I think, what I want to do. How deep am I extruding? That was the question I started with. I want this face flush with this face. So really, I just need to know the depth. 732. 7.5 is not enough. That's only 10 thou. We're going to go 8.75 deep to give us an 1/8 of an inch wall. Nope. I take that back deeper because we need... Did I ever get M2.5? These were the M5s. I need the heat set inserts because I need to know how big or how deep the hole needs to be. We're going to go M2.5. We're going to go with the biggest depth they got, which is this one. Material thickness 6.5 millimeters, 6.5. Again, convert 25.4. A little over a quarter inch, 256. So we need a quarter inch of material on top of. We need a quarter of an inch of material on top of this thickness. So that's already at an inch. We need to go an inch and an eighth deep, at least. Sounds like a good round number, right? We need to go an inch and an eighth deep. And then this guy, I want, can I do it concentric? Coincident? Hey, look at you. Now we're perfectly centered on that screw boss. Look at that. I can make that line perfectly line up with that, with where that hole is going to be. It's going to be perfect. And we need, accept that sketch. And I said we wanted that to extrude an inch, 1.125 in the other direction. We are into the battery compartment. However, that's not a terrible place to be. Because we're not, well, we're into the battery compartment plastic. Excuse me. Where we are not is into the battery compartment itself, right? If we had gone deep enough to be into where the battery sits, that would be a problem. We did not go that deep. Why is that a separate color? That is a separate part. I don't like that. No. Why did you do that? Why did you do that? Did I not? Why are you a separate part? Was there a merge? I mean, SolidWorks used to have a, let me see, SolidWorks has a merge. Add, there we go. I was on the wrong damn tab. Oh, God, scare me like that. I mean, not that it would have made a huge difference. So this, it's going to be way uglier than I was hoping. It's going to be way uglier than I was hoping. We can get, I'll tell you what we'll do. We'll pretty that up later with, like, say, a massive chamfer. Because we got extra material here to play with. I can do something crazy like chamfer that. And it doesn't even have to be equal distance. It can be two distances. Distance 1, distance 2, right? And I mean, I can basically, I don't know which one's which, honestly. Let's do 0.1 there. So, I mean, I can play with it, but 0.05, you know, make a huge chamfer like that. We can later on make it pretty. I could even do something completely nuts, like cut a very shallow arc so that it's like perfectly tangent and all. Yeah, yeah, not worried about it. It's ugly right now. I'm honestly used to. My usual workflow is the style that I mentioned before, where I would have made this one big block and started cutting pieces out. The difference being that to do this and do this properly, by adding, I just have to get over some of that stuff and know that we can do little tricks at the end. So I think, I mean, we're getting close. I don't like to run this more than like 2 hours if I can help it. And I think the last thing I'm going to do is just sort of cut out. Do I even want to do? Let's show this sketch first. Let's just do that because it's got the holes and that's where we want the motor to land, right? And everything's going to be sort of based off of where those holes are. The holes are the most important part. The pocket can be oversized, you know, ridiculously. So those holes are the important part. And we need to make a cut. How do we do that? Maybe I will call this here. Because this cut is not as simple as it seems. So what is going to have to happen I need to cut the full depth of this motor, except for where this tab is, I need to cut less than half because it has to have some plastic to sit on and an insert to go into. And that's going to take some measuring and scheming, which honestly isn't too terrible. Like, we're going to sit in here somewhere like this. Not too terrible, yeah, but it's getting late and I'm getting tired. So I think right now, I think that's where we're going to call this stream. That's a good place to stop. That is where I will pick it up. Again, the week gap between streams kind of sucked. You know, it was hard not to finish this. I thought about it quite a bit, but I'm going to switch over to the full screen. Again, thanks for watching. I hope you find these useful. I'm going to keep doing them, even if it's just me talking to myself. Because I mean, part of it is hopefully you get some use out of an engineer with a lot of SolidWorks experience talking through some of these design decisions. Some of them are measured, some of them are completely made up. I'm fully willing to admit that. But the other part of this is, again, as a teacher nowadays, I don't get to do a lot of this engineering work, and sometimes I got to have a little fun too. And I truly enjoy this. I nerd out over it. Hopefully, that much is obvious in these videos. So I'm going to go ahead and call the stream there. I want to thank everyone for tuning in. Thanks for watching. And if you're watching this later, hi, drop a comment. And we'll see you next week. Same time. We'll pick up right here, get these motors put in. Yeah, go from there and start to get some of the other bling type stuff in. So have a good night, and we'll see you next week.